Hello and welcome everyone to Architecture Engineering for the Space Elevator, presented by International Space Elevator Consortium. Today with us is Michael Fitzgerald. He is the Chief Architect and Board Member of ISEC, who will take us through his galactic harbor. So I am going to turn things over to Mr. Fitzgerald, and when you see your first slide, please.
Okay, good morning. If you can't hear me, then you can't answer my question of can you hear me? But in any regard, good morning indeed. I am at, I'll show you where I am in a chart or two. It's bright and early out here, and for the first time in a few days, it's chilly. I'd like to welcome my friends. I don't know if y'all are looking at the chat. We have people from India. We're expecting people from Spain. Even my brother-in-law is on there. He's in Melbourne, Florida, not too far from you, Dennis Polis. And my schoolmate, Dave Anholt, and a former professor at the Academy, Colonel Santiago, is on board. Some conspiracy members, Greg Orndorff being one of them, and of course the board. And there's my classmate, Hunter. He must have overslept. Okay. I think Hunter's in the track of the hurricane, so if you make the connection between hurricanes and Hunter, then you understand what I'm talking about. All right, let me get started. Here's the game plan. I'm going to go through this quickly. I intend to describe the entire architecture and the aspect of what architecture engineering brings to a galactic harbor or any other major project, if you want to know the truth. I am very proud of the fact that architecture engineering is a term I began using almost 35 years ago in association with the projects I was working then, which are mostly not spoken about even to this day. Okay. That's who I am. I graduated from the Academy in 1968, and basically after an exciting 12 months exactly in Vietnam, I got involved in space. They finally declassified my Southeast Asia space program for the first time in 45 years or some craziness. This is what we'll cover. I'll describe the galactic harbor. I'll describe how it's made up of the segments. I'll begin to describe what architecture engineering is and what makes it unique to not only the galactic harbor, but big projects. Then I want to go through a little bit slowly about how we're managing the technology maturity, read that technology needs, if you wish. Then the magic of the galactic harbor and the space elevator are in a couple charts near the end. And we're going to explain to all of you that this is not a space project. It's a transportation project in space. And that's the way we think. All right, what is the galactic harbor? Well, I gotta find my pointer, Karen. I lost it again. Oh, there
Up
it
at the
is.
top, there's like a little arrow. There you go.
There you go. Where did it go? There it is. All right. I live right about there. Okay. I go to church right about there. Oops, I missed that a little bit. Right there. And then when I got up in the morning for the last 40 plus years, I'd get on the freeway and go up to El Segundo there. But this is the Los Angeles and Long Beach Harbor. If you were to drive follow the green arrow, from here to there, you'd be able to get to here, which is where they hold the Long Beach Grand Prix. In the course of making that about 5-mile trip, you will go past somewhere between 200,000 and 250,000 containers that are either getting off or getting back on container ships. Most of them are in areas that are marked in red, and those areas in red especially were reconstructed or constructed, turning this combo harbor into a major harbor. Now, follow the green arrow. This is the breakwater. If you're on a ship, you come in here, and here's the major point. You go like so. That is the main channel of the harbors, and that is where the ships actually go. All right, you dig? The main channel. There's a correlation between the main channel and the space elevator. That harbor, amazingly, is the home, or sort of the home, of over 1 million jobs in the Southwest United States. I'm trying to give you the scope of things. And my favorite story about scope is a guy named Bill in 1947 was starting a housing project, and the reporter asked him if his houses were going to have that fancy new washer-dryer combination that had just came on the market. And Bill looked at the reporter and said, "Young man, I do not build houses, I build towns." His name was Bill Levitt, as in Levittown, and I want to take the same perspective for the next 30 charts. It is a transportation story, and the purpose of the transportation system is to produce, follow the green arrow, reliable, safe, and efficient access to space. And in a paper that Dr. Swan is currently writing, and you'll see in a week or two, depending on other timing factors, we're not trying to steal business from the rocket guys. We're trying to make business for everybody. The galactic harbor is composed of two macro pieces: the transportation system, which is, as I said, the main channel. It has 6 basic segments, and I'll touch each of them in a moment. And the other half of the galactic harbor is this right here, that the harbor and the transportation system will allow businesses to flourish. And that's the real purpose of going to space for the sake of mankind. All right? How am I doing? You got it? Here's the chart you'll see in a lot of our publications. The galactic harbor space elevator main channel is 100,000 kilometers tall in our basic concept. You'll see things at the end that will indicate it could be larger than that, taller than that. And that's the galactic harbor. If you got questions, write them down. We'll try to answer them in the first hour. If you don't get an answer on this telecast or webcast, Karen and I will work out, and I will get an answer to you. All right? I will get an answer to you. If at least to tell you, I don't know the answer, okay? God bless you. All right, the segment descriptions. The Earthport. This is the first, the foundation. This is the place where the space elevator is attached. It will be floating in the Pacific, undoubtedly. And this is the most mature segment, as you can hopefully see. Now, container ship here, it comes around and drops off its containers here. These are containers that hold stuff headed to space. Let me keep it simple, okay? This floating operations platform has, I don't know, a couple, 300 people living there in these offices here. There's houses, and these little windows are rooms. And there is Vern's tennis court and Pete Swan's swimming pool. And over here is Pete Swan's driving range. And over here is the blackjack table for me. The top 2 floors is where the operations of the entire galactic harbor will be managed. That's a big story. Basically, we're going to go near real-time awareness of everything in the galactic harbor. Now let me flash back to the LA harbor. I said about 250,000 containers. Every single one of those containers is managed intimately in a data sequence of things called the Internet of Things. We intend to do the same thing for everything in the galactic harbor. All right, here's the operations deck in terms of flight operations for the helicopter, managing the security boats that are floating around, and a real farm of communications. A little more about this, a quick shot. This is the same shot, but down at a lower level. This is 13 bays, and this is where the stuff is palletized and would be put on the climber and perhaps put on this vessel or perhaps a smaller one and taken over to the Tether terminus. The image is slightly misformed here, but you get the drift. This is the Tether. There's a quick view of what a climber might look at. I'll get to that in a bit. And each galactic harbor is envisioned to have at least 2 of these tethers. All right. How am I doing? You with me on this? We're also thinking already about how, in this case, the Earth port might change. This is an example of a change under consideration. It's called a multi-stage space elevator. John Mattman is on the call. Yeah, there's his name. All right. There's everybody that played in that book. In this case, this is where the Earthport floating ops platform is. The packages may well be prepared in a similar way, but they'll be, quote, tossed up in streams of bolts, like maglev type lifting, if you will. This report is available on the ISEC site free of charge. Just send a wink and a nod to John Knappman, who put a lot of work. He is currently building a prototype, and right here, all right, right there is the end of the Earth port, just like there may in fact need to be an interim platform, which is shown down here, or two platforms. John's sorting that out for us. That's an exciting development activity going on right now. Now, my favorite region is probably, for all you space nerds, is the Geo Region. 7+ years ago, this is what it looked like. This is about, we don't know exactly, but it was 300 or 400 meters across. It was a big satellite. And here's the tether going through it, and here's the climber on the tether headed further up. This is what we think the Geo Region looks like now. We think it's 200+ kilometers across. We think it has parking lot orbits. Climbers stop and drop stuff off or proceed on to the apex. These green oblong things are surveillance satellites keeping track of everything they see in the Geo Region and beyond. Whoops. Geo Region and beyond. We're looking at various orbits, or actually Dr. Swan is, at how to get these to be geosynchronous. This is the point of geosynchronicity right there, all right? This would be the geo belt going left to right across the image. This is an amazing step in engineering. The size of this reaches from San Diego to above Santa Barbara in some of our considerations, especially when we get to the later parts. After IOC, we will have added a multifunction operations center up there. There'll be several parking orbits. This is where satellites will be serviced. This is a dropped off climber. We are not in charge of shuttlecraft. We'll rent that service when necessary, but something brought in by this climber could be used over here or over here. That entire set of operations is the Space Elevator Enterprise concept. And hopefully I'm moving through all this. This is the new and exciting part of the APEX.
We have a poll, I believe.
Yes, I'm sorry. Yes.
So I just want to interrupt Fitzer here. So we just went through the Geo Region, and so we'd like to gather your responses to what businesses should be a part of the Geo Region enterprise. And you can see there's just a little pod, or a little typing area there, so it's sort of short answer. So please feel free to just type your response in, and then you will be able to, sorry about that. Then you will be able to give us your answer by hitting the arrow. So let me just pull that over again. There we go. Here we go. So there's at the end of where you type in the results, there's a return. You can just hit return, and then we can gather your answers. So give us your best shot. What businesses do you think should be part of that region? And I'm going to give you a few seconds to kind of gather that. A lot of things are coming in, some very interesting things. So Fitzer, I see you can see those answers, right?
Yes, yes, indeed.
Okay. So we aren't showing these to anyone in the audience as of yet. So we'll give everyone a few more minutes, or seconds actually. I'm over
And then
exaggerating.
y'all will see all of them.
Yeah, we'll broadcast them in just a minute. I'm just going to give you about 10 more seconds.
I would think a base for asteroid mining would be perhaps a slightly better version of that one.
So if anyone needs a little more time, just just let me know. Type in chat, say need more time.
Nobody's got 3D printing in yet.
Okay.
Stuff.
All right, so I'm going to broadcast the results so that we all can see it. So everyone should be able to see our answers there. And we have several people said hotel, space manufacturing, Army Corps of Engineers, energy supply, anything interested in space, our future off planet.
Or transportation.
Yes, or transportation, replacements, telecommunications, and tourism. I think that's a very interesting one. I think they're looking down on Earth, from what I've read from people who've been up in the ISS or other spacecraft up there. They have said seeing Earth is just amazing, and I think that would be a great tourism. But lots of different things here. All right.
Colonel Santiago, I thought you might have suggested there ought to be a school up there, a training session. You know, on-the-job training. Just to pick on you.
All right, so I'm just going to go ahead and just get the poll, and we'll go back to our presentation.
All right, thanks, Karen. And everybody will see everything. And if you have any further ideas, then I think you can see that a lot of people have a lot of sense of what the Geo Region is going to be. Interestingly, very little of the Geo Region is actually part of the space elevator transportation system. If you look at this slide that I have up now, the Geo Region after IOC, you see this pathway through it. And perhaps you might imagine a stop here somewhere. That's the transportation system. The rest of the grayed-in area is really where the enterprises will operate. Now, we believe that most of the enterprises will actually be in small figure-8 orbits, perhaps 80 clicks up and 80 clicks down. And the service positions will be in shorter orbits, so they would, more easily be accessed from the center of operations here. But anyway, just to give you some thoughts as to what you might want to do. I thought Mike Tabbitt would have a list on me by now. Sorry, Mike, had to pick on you. All right, the apex region. This is still a story not yet done, but the truth of the matter is, let's understand the apex to start with. First of all, from a transportation system, you'll notice that blue line that I indicated in the previous chart, this is where the transportation system comes to an end. This is the counterweight. This is the deployment or accumulation of deployment satellites. They are the counterweight holding up the whole darn thing. And the apex, the enterprise part of the apex, has some sort of facility up there and holds everything together. See, if you jump off the apex, you go away. You jump off something at geo, you just go into a soft orbit around the geosynchronous point. This place is different than the geo region, and the geo region is different than the Earth port. And you say to yourself, aha, that's why this is an architecture and not a system of systems. Because, and I'll get to the answer to that question. The major aspect of the apex region is the fact that this is where flight operations for interplanetary destinations will occur. You jump off, you're off to Mars. If you want to get back to Earth and you're on Mars, you got to come here and land. All right? That's a pun. This chart is what redefines the word earthbound. It used to be if you were earthbound, you were stuck on the planet Earth. Now earthbound means, hang on, let me find my arrow again. Ta-da! Wherever it is, I lost it. There it is. If you're coming down this track here, you're earthbound. A new definition of an old word. It's intriguing how you say things. The tether, piece of cake. Wrong. This is the thing that makes this work. The tether, we believe, will be made of single crystal graphene or versions of that or some other molecular structured material. And this, for example, each of these 100,000 kilometer long layers, if you will, weighs about 44 kilograms, amazingly. But yet it's strong enough, 4 or 5 of them are strong enough to hold up the entire space elevator transportation system. It's an amazing material. And Adrian Nixon, who's on the meeting this morning, has a webinar that's recorded, and you can go to the ISEC website and listen to Adrian go through the story. It's an amazing story. Now, what makes this all architecture engineering? It's really pretty simple. I started this process, architecture engineering, about 35 or 40 years ago or more. And I took a look at what system engineering was, shown here on the left. And that's a master's degree in system engineering. And I said, nope, that's not the way I want to build things. Now, in the case of the space elevator and the galactic harbor, there are 4 main elements. Okay, and I've shown them with the red dots. There is nothing more incompatible than a floating ops platform in the middle of the Pacific Ocean and the apex region up in space. One's in outer space, one's in the middle of the water. The environments are different, the functionalities are different. They are, in essence, incompatible. Architecture engineering deals with that. And that's what we're all about. One of the ways they deal with that is recognizing that the interfaces, either the direct interfaces or the functional interfaces, have to be intelligent. The sender has to be aware of the receiver, and most of that is resolved with information exchanges and awareness of who this segment is talking to and which segment he is listening to. The third major aspect of the space elevator, and we're still a little weak here, just to be nasty with ourselves, is that modeling and simulations become the operational execution plan and allow us not only to seek operational alternatives, but also to avoid anomalies. If you're up in space, anomalies are not your favorite subject. We need number 5 here if we're really going to have a galactic harbor. And lastly, of secondary importance in a broad sense, but importance nonetheless, is that this thing will adapt. It will adapt to the businesses that are using the elevator. There are businesses that are using the harbor. And that adaptive evolution is covered in my writings called Sequences, and Pete Swan has, and Peter Robinson and others have expanded on that notion of adaptive evolution. And in a sense, we don't know exactly what we're talking about, but we know we have to adapt to the future. Duh. Now, in that adaptation process, we have to pay attention to what technology does. So there's 4 stages of maturity. The feasibility of some technology to do what some segment wants to do. For example, the Earthport floating ops platform, and I didn't point it out at the time, but about 2/3 of it or so, or whatever, is below the surface of the water. It's a semi-submersible. It is very stable. That maritime technology is relatively mature, but it's maturing all the time, especially in certain efficiencies and powers. Secondly, the idea of keeping track of everything across 20 or 30 trillion cubic miles is a technology that we're anxious to worry about. And we are right here And after now, we're going to go through an engineering validation phase, a design. We're going to build it about here and go into operations. That's the roadmap that we're working. And let me go to the next slide, which shows you what did we do in the first phase. If you look at all the writings on our website, we did in fact document the technology and its readiness. We came up with a rationale for the readiness level. In our case, the rationale was whether or not you could find it in industry, and then we correlated it to the technology readiness levels, which is more or less the industry standard. And last step in that first phase was that we set the criteria for how we would approach engineering verification and validation in the second phase. That's all documented in about 20 or 30 pages in this document, something that several of us wrote about 6 years ago now, amazingly. I'm starting to feel old. The point of all that is we took technology feasibility at this point and we did a preliminary technology readiness assessment. For those of you that have been in procurement, you know that a technology readiness assessment is when a senior vice president on the commercial side and maybe some general officer on the government side, it says, okay, let's see if we can build it, which is, in fact, what the engineering validation phase is. A slightly different version of that, and one that we're going to pay attention to, is we're going to ask industry to start doing some technology readiness. Let me make an important point here. This is per segment. There's a TRA needed for the earthport. There's a TRA needed for the Geo Region. Generally speaking, that's a new approach as well. But that's why we're going to industry. We're going to go to the space industry for space stuff and the maritime industry for maritime stuff. And what are they going to do in the second phase? I'll leave it at this chart. I have a backup which will come with the package that Karen will send out in a few days, detailing what all of these things mean. But let me make one point. Number 6. When we're done doing 1, 2, 3, 4, 5, then we will know the technical performance of the galactic harbor in all of its segments. We're at a very important phase in the development of this, the largest civil engineering project in the history of mankind. Okay, it's a big deal. And we're ready to go. And we're very proud of the fact that people like the international dudes have said, we're ready to go. A couple more charts just to make a point. This is something I borrowed from my good friends at the Skunk Works. I worked with them for 15 or 20 years, and I kind of had to, break it into pieces so that they wouldn't give away their secrets. This had to do with a flight vehicle that nobody had ever built before. It went really fast. And you'll note experiments, demonstrations. This mark right here, milestone B, that's the equivalent of the start of engineering validation. Look at the way they did this. They said, all right, Mr. Senior Vice President, we're going to take this TRL to 6, then to 7, then to 7 over again on a slightly different vehicle, then to TRL 8, and they were taking certain aspects of their program before they got go-ahead to a high level of tech readiness. If you learn anything this morning, that's the secret of the Skunk Works. Now look over here, high fidelity simulation, ConOps demonstration. You'll note the tech readiness of those things is a lagging indicator or performance, and even the Skunk Works can't keep up with itself sometimes, is what that means. All right. We documented this in a document called Sequences. I won't go through that rain dance, but the idea is you start and you demo, practice, operate, do it over, and adapt. That's what Sequences is all about. Again, that document is a new twist on development that the Galactic Harbor has brought forward. I'll allow you to read this carefully. The idea is that if you want to know where you are from a tech readiness standpoint, am I ready for performance? you go over and you look at your segments or your subsegments performance in the sequences. All right. This is sequence number 3, and if you're worried about the design, okay, you go get the sequence 3 test data. All right. That's what this scheme is all about. This is the sequences I'm talking about, not these blue boxes. This is the sequence of whether or not you're ready for engineering and delivery. And what's nice about the sequences is it's great to visualize, and even senior vice presidents understand it. That's a joke, Pete. That's a joke. All right, here's the magic elixir of this.
We have a poll.
2 charts to go. Hang in there.
Oh, all right.
No, Karen. No, that's for the guys and the gals. Go ahead with your story. That's important.
Okay, yeah, because I know the next one is in reference to this. So we have this question about the window departure from the galactic harbor to Mars. So we want to get your ideas. Some of you know some of these answers because you've been part of the studies in ISEC, but please answer, where do you think the window of departure from the galactic harbor to Mars is? I'm going to see how many people can answer. We're getting more coming in and more coming in, which is great. Few more. And we know we just sent a probe up to Mars.
Yep.
Not via galactic harbor, though, so.
Yeah. Dave Anholt, you better have voted.
All right, I'm going to give you a couple more seconds, maybe 10 more seconds. So get your vote in. Some people are deciding. Looks like everyone who's voting has voted, so I'm going to show those results. You can see the results. You can't send it in. You just go ahead and click it. There's no submit button. So whatever you click, it will record your response. It isn't closed. So everyone can see the answers or the responses now. So we have 7 people saying every 26 months, 11 say every day, every 45 months is 3. And nobody said every year.
Oh, I thought Anholt would say every year. He's sort of
So those are our responses.
Yeah. Okay.
All right, so I'm going to go ahead and hide that poll. Now we're going to reveal.
This is the story from a transportation standpoint. You know, Amazon Prime says if you remember Amazon Prime, free delivery. You'll get it tomorrow. Well, we can't quite do that. But we can if you get to the apex, depart every day. Because as this thing, where's my arrow? As this thing swings around, and the earth is spinning. All right? Colonel Santiago knew that. So it's spinning around. Every day it comes to a point here or anywhere on this extended tether. All right? You can send something with enough velocity, in this case 7.76 kilometers per second. It has enough free velocity and get to Mars. So every day there can be a Mars departure. And let's see, jump in here and correct me if I'm wrong, Pete. This one's the asteroid belt, or is that Jupiter? I always get these wrong. Give me an answer on the chat line. There's different destinations available by these extensions. Now that's an operational dynamic problem that we have to pay attention to. We can't just do it willy-nilly. Okay, the top one is for solar system escape. Is that the idea? All right. Dave Anhal's learning how to type. Okay, I got it. All right. So you can, look, free delivery in the solar system, if you can get to the apex. And it doesn't matter whether you're sending a matchbox or an assembled spacecraft the size of the Enterprise. If it's at the apex, we can send it somewhere, and it's just a release. Now this discussion, these calculations, oops. There we go. Were calculated under Dr. Swan's guidance by a young man named James Torla at the Arizona State University, and he was led from an educational standpoint by Matthew Pete, the professor that Pete Swan worked with. This document, correct me if I'm wrong, Pete, is available on the ISEC. This is an amazing story. You don't need a rocket to get from the apex to anywhere in the near solar system. You dig? That's a story. That's a hell of a story. And why do we need to do that? Well, if we had 3 galactic harbors, we could deliver 175 metric tons per year anywhere in the solar system. That's kind of handy. Why do we need 175,000 metric tons? Because with a quick examination, Dr. Swan has identified 174,000 metric tons need to be delivered. And by the way, these are the only ones he could find numbers for. There are other delivery needs that he couldn't find numbers for, and it's not on that list. So you know the number's bigger. That's the story. That's the story. All right. Now, what we're doing here is taking a look at what I talked about when I was at the Los Angeles Harbor, the intermodal container-based shipping network. Stuff comes into the Los Angeles Harbor. Where's my arrow? There it is. Comes in on these big container ships. Some of these container ships had 5,000 and 6,000 and 8,000 containers on them. Those containers left by truck or by train, and some of them were broken down and put on flights out of Long Beach Airport and LAX and whatnot. What we're saying is you got to take them up. Take them up the elevator. Right now, all we can do is take them up on rockets, but we're going to take them up the elevator and deliver them anywhere in the solar system. That's the galactic harbor story. It takes the 2-dimensional network on the planet Earth and makes it 3-dimensional. And it would take us 15 years to build this thing as soon as we get started. And I'm ready. Okay, not bad, 37 minutes. We got 30 minutes, guys. Send in your questions, and I guess, Karen, you read them? Is that the way this works?
Sure, I will. Now, there were a couple of questions that actually our President Pete Swan answered, but I will see if you would like to add any comments. So one of the first questions was, is there an issue with lightning in the atmosphere striking the tether? And
well, yeah, of course there is, but we're aware of it. That likelihood and the magnitude of that is understood, and I think we understand it well enough to say that it's an operational problem or an operational topic. It's not really a showstopper. I
Yep.
didn't see what Pete.
And then there was another question about asking about the intense gravitational force, which has to be defined when traveling up, and the force while coming down. How is it planned to be stabilized, related, I believe, to the rotation of the Earth? And that also comes into play. And he wonders how those factors are overcome.
Well, on a couple of my, let me augment what Pete Swan said. A couple of my we know how to map gravity. Let me put it to you that way. Um, a number of my projects, especially the mobile ICBM project I worked on, we mapped microgravity, and I forget the metric resolution. But yes, we are going, just like we're going to figure out what the ocean's doing down with the airport, and make sure it doesn't get washed away. We're going to map the blank. We're going to keep mapping gravity. We're going to pay attention if there's changes, but we're going to map gravity as is. It's a fairly stable number, but I don't know if we can say that with 100.000% certainty, because we do orbit around other gravitational forces. And Peter Robinson will take the question and hand it to Mike McCullough, and we'll get the other answer. We're going to pay attention to that. But the real question in my mind, Pete, jump in here, is that it's actually more dangerous to re-enter because of gravity than it is to climb out. Dangerous. So if take danger as an attribute, we have to pay attention. If anybody in the audience read the Fountains of Paradise, that's almost what killed the hero of the book, because he didn't pay attention to gravity when he was coming down.
We've got a couple more questions. So one question is, what are the most likely showstoppers? I'm assuming for this entire transportation system.
Okay, that falls into the category of I don't build houses, I build towns. There are a number of things that we'd like to have better. I think the showstoppers would be over on the political side, and in the sense that we're going to have to park this thing in the middle of the ocean, and it's not a sovereign location. I think that will slow us down. I have not mentioned, for obvious reasons perhaps, is that the Chinese and the Japanese have already started building there, and I don't think they will have the same kind of showstoppers in that regard. So political showstoppers, sovereignty showstoppers, legal showstoppers, not so much, I don't think.
Next question. Oh, sorry.
I was just going to say that's it. I hate to go around looking for trouble, but those are the three trouble spots I'd look at.
And then next, you talk about the galactic harbor taking 15 years. So someone asks, how does the 15-year effort get funded?
Well, duh. You got an answer? Right now, the board is pondering all sorts of techniques, and our basic technique is to get out and get talked about. We think there's some political venues that might actually get us a little of the granting, but we believe that the funding will come from commercial sources. Most of the Transcontinental Railroad, correct me if I'm wrong, Dr. Swan, most of the Transcontinental Railroad was funded by Vanderbilt and Andrew Carnegie, but it was kicked off, it was authorized, or whatever the word is, by the need for getting to the West Coast. California was a state, and it was not really part of the Union. Those kind of forces were out there and about. So political and government forces started with some level of funding, but Andrew Carnegie and I forget Vanderbilt's first name, but it was commercially funded.
All right.
And Randolph Scott had a big thing to do. I saw the movie.
And there's also a question about cargo going downstream, I guess, down from the tether. He asks about potential use cases. He comes up with resources from asteroid mining or mining the moon. What other use cases do you think are relevant?
Well, okay. There's two answers to that question. The first answer is to punt and give it over to the enterprise people. The stuff coming back from asteroids is up to the asteroid company. You dig? We would offer them power and a place to do, smelting or whatever in the hell at Geo somewhere. I don't. You may want to ask about the idea that smelting would create um, toxic material. Well, the best way to get rid of toxic material is to take it up to the elevator and toss it at the sun. See, so we're answering a lot of the questions, other questions that I don't know what remaining questions they have. Whoever asked that question, I lost track. But sending some of that stuff to the earth should fall into more of a finished product thing. If I had all, um, we'll get you a better answer on the write-ins, okay? Every one of these questions will be re-edited. So,
And then, yeah, and then another question, what are the challenges and mitigation of space junk in LEO as you build and operate the elevator?
well, first of all, there are 2 or 3, depending on how you count, reports that we've produced showing what the likelihood of a collision is um, with the tether and or the climber, and objects at Geo Region for that matter. Um, but in the debris belt itself, it's really the climber and the tether. Secondly, there's new thrust to understanding that problem. First of all, there's a better management of the error bounds around the targets, quote unquote, and the debris. And secondly, there's at least 2 initiatives that I know of, supported by the U.S. government, to start debris mitigation programs, and they will be in effect and operating by 2030 or so. We do not think it's anything more than an operational problem. We can move the tether. We can ask our partner in the debris mitigation adjunct, that's another document the audience should read, who then intercept the debris before it comes close to us. We have solutions, and they're detailed pretty much in both documents that we've produced.
All right, and then
If you didn't get confidence in that answer, you weren't listening. We got it. Is sort of what the answer is. We got it.
okay, and then we have a question that was 2 parts. So, how does your philosophy from architectural engineering relate to Will Roper's digital holy trinity, including digital engineering, meaning a digital twin model, agile software development, open systems interoperability?
Well, those are terms that, in my mind, link back to an innovative approach to building things. And those innovations occurred mostly in the commercial arena. We're expecting that. We think that the are you still there? Yes. We think, well, first of all, the list of those things are legitimate, but they come from the segments, Dave. It's important that the people that are building the segments are on top of their game. Okay, I'll give you that. But I don't think I have to mandate that as the chief architect for all the segments. I don't have to mandate that to each segment, because those segment developers will be in competition with each other to get stuff done. Okay? That's where I'm at on that topic.
Next question. Pete's starting to answer, but the next question has to do with cosmic rays. What about the cosmic rays and space radiation, and how is that planned to be tackled?
Well, once again, see, when you build something, you sort of pay attention to the environment in which your segment operates. And the rays and radiation environments are understood, at least out to Geo. I think we might have some environmental mapping out near the apex, because we haven't spent a lot of time out there. And one of the first things, if I was totally in charge, and I am, I would put sensors out there as soon as the apex became the apex. As soon as those deployment satellites came to a stop at 100,000 kilometers, I turned those sensors on and start clocking all that. And that would occur All right. Let me use my talk. That would occur by sequence 4, if I remember right, maybe even sequence number 3, which would be 6 to 8 years before operations start. So when the operators show up, we'll understand the problem.
Okay. And there is a question that Peter Robinson started answering, and maybe you'd like to elaborate or just talk about.
Yeah,
Will the
keep
Geo
going.
Enterprise region be a nuclear-free zone from the standpoint of nuclear energy for smelting and other high-power needs? And Peter Robinson answered, the nuclear energy is not needed because there's going to be plenty of solar power.
I think yes, I think Peter has nailed the argument. There may be some exceptions in terms of thermal ranges that nuclear events permit in the smelting process. But let me tell you a secret. If I owned a train, I would power each car in that train. And if somebody wanted to bring their own power source, they'd have to meet my specs, not theirs. If they need a nuclear thing, we probably would move that smelting stuff down the geobelt a bit, and they'd have their own little room. They would not, you follow my logic?
Mm-hmm.
Just on that train, I put them in the caboose, and as soon as I had a problem, I let the caboose go. In my reference point, if somebody wants to use nuclear thermal attributes in the smelting process, I'd find a spot for them where they wouldn't be dangerous to others.
Okay, and then we have a couple of questions I put over in that questions pod having to do with some business model, finance, industrial partners, all in questions, as well as is there an entity in place to solicit and receive funding, and what would be the amount of the initial funding? I don't know if you want to address those or if those are really something to get into the weeds at a later date.
I think that's a later date thing. But by the way, let me answer it this way. Um, a number of us in me and a number of us in the audience said there's 3 answers to questions: yes and no, and I do not know, but I'll go find out. That question falls into the 3rd column. We are looking for what that's all about. How to handle what kind of finances as they come in. I talked to a finance guy the other day. Those were part of the questions, but no, we don't have those answers yet. We'll have them soon, by God, and we'll have them before the money shows up, which doesn't seem to be a problem in that regard.
Right, so those are the questions that we have so far. We've been talking about the transportation story. Our chief architect with ISEC here, Michael Fitzgerald, has really laid out this great story for us. And so we're almost at the end of our time, but I wanted to see if we had some additional questions. I see some people typing, so we'll just wait a few minutes. There is a ISEC.org is our website. I have put some of the ISEC studies that Fitzer referenced in this presentation. They're down underneath that chat pod. You can download those studies right here. They're all PDFs. We also have that and more studies that ISEC has been pulling together for almost 10 years now, and that's at isec.org/studies, and I'm just going to put that in our chat here so you have that. There is a number of studies.
And Karen, I got one more statement to make. In the classic case of as soon as you answer a question, you engender another question. We believe in that extensively and thoroughly. In that regard, the ISEC board, and with all the humility, me and Pete and Vern Hall have, in a sense, stood up a Space Elevator Institute. It's a think tank. It helps us define the questions that need to be answered and helps answer the questions. The Space Elevator Institute, we are actively seeking funds to endow that approach. And some of the things I could say go a little far in terms of the fact that, yes, we're beginning to get money interest in that. The Space Elevator Institute, if anybody wants to know anything more about that, send a note to me and to Dr. Swan or just Karen. Karen will get it to us, and it's a big deal, or it's going to be a big deal.
Right. So if there are other questions that you think of after this presentation that you want an answer to, I put my email in there. I'm going to be collecting all those questions plus giving the questions that occurred in this session to Fitzer here. And we can have conversations. We can continue the conversation. So just make sure you email me with additional questions. And of course, Pete Swan, our president at ISEC, also put his email in there so as to be a point of contact for additional questions and additional conversations we would love to have with you. Another question has come in. Would it be possible to have different tether links in the same spaceport if the traffic needs are different for different regions?
Okay, the answer is, once again, yes, no, and I don't know. Yes is the real answer, but that leaves us with some construction variants that we have not yet even validated. So that question is very important because, for one thing, one climber may have to pass another. When you get to the Geo Region, you may want to have side, places to park for an hour or so because the tug is late getting to it. Yes, the answer to that question is yes. Eduardo, are you with Sovic or are you with Valentine? I forget. Okay, well, just let me know. Why don't you make sure that question gets to me again, Karen?
I will.
It's a little bit more than just a yes and no, because we're in space, for heaven's sakes, and different physics apply.
Right, and I have your email addresses that you registered with, so I am curated this entire chat, and I know we did answer those questions in this session, but I also will be sending that to Fitzer with your email addresses because he may have some thoughts after the session to maybe continue the conversation with you if there's something else that needs to be addressed. So we're going to continue the conversation on this. We really are presenting these webinars out to our global community. We hope that we can really generate some really great interest because this is certainly something that's going to help us all get to space, and that's really what we want, is to get off world. So thank you so much.
Karen, let me take the off the stage remark. I showed you where I live. I live down about 30 yards outside of San Pedro, about a mile and a half from where Elon Musk is going to assemble or likely assemble the big Falcon rocket and the Starship and whatnot. The truth of the matter is that we're in the process of trying to convince Elon, who doesn't listen, but we're trying to convince his people that instead of taking his assembly of the Starship to the Los Angeles harbor, that he should take it to the Galactic harbor. All right? And I think he will understand that question when it finally gets put on his desk sometime the next month or two. Okay? Elon Musk has not seen this presentation, but he will. Thank you, guys and gals.
Thanks, everyone. If you do have we're come to our end of our time here, so I'm just going to switch over back here.
Over now.
And I just want to thank Michael Fitzgerald, our chief architect and board member with ISEC, to bringing us that great story. I do have some other things for you. We have a newsletter, a monthly newsletter that is chock full of information. Go to isec.org, go down to the bottom. You can sign up for our newsletter free of charge. You do not need to be a member of ISEC. However, we would love for you to be a member. And currently, these are our rates for membership, and they are quite reasonable. As you can see, it's a yearly membership rate. We are going to be raising rates in the next couple of months. This helps cover our costs for our nonprofit here. So if you'd like to join, that button right there, you can click that join button, and that will take you to the page where you can subscribe for membership. And we have some additional membership benefits that we're going to have. We are going to have a members only webinar, which is going to occur in October, and you'll get more information in the newsletter as well as on our website. But that members only is going to be a real great brain trust of the people who've been working on the space elevator for years and years. And we're going to do some mini presentations, and you can really get your head around what the space elevator, what the galactic harbor, what the entire transportation story is. So you can get excited as we are excited. Our next webinar will be listed there at isec.org/events. And we do want to thank our sponsors. Technology is provided by Adobe Connect. That's the platform we've been using. You can go to them and find out how to have some really great interactive sessions. This has also been sponsored by the Learning Guild, who is the company I work for, who has allowed us to sort of put me on loan and allow me to run this session for you. And my name is Karen Gleason. I've been your webinar producer, and I do these kinds of events for other people other than the Learning Guild. So if you'd like to learn more, you can get in touch. You can click any of those logos and you can find out more information. So thank you so much for joining us today. Have a great rest of your day and have a great weekend, and we'll see you in space.